Hello friends, in the current video tutorial I am going to talk about compose function in strings and characters toolbox in MATLAB. So let's start with it. So string is equal to compose format specification. A is the syntax for this compose function. It formats data values from the input array, which is A, using the format operator specified by the format specification and returns the resulting text in the string. The compose function formats values from A in a column order. So if format specification is a string array, then so is the output array str. Otherwise the str is a cell array of character vectors. So this means if the format specification is a string array, output will also be a string array. If the format specification is in the form of a character vector, so output will be a cell array of character vectors. So let's run this program and see. So first program is this. We have got this A is equal to pi format specification. The format specification is a is in the form of a uh, string scalar. So it is percentage 0.7f, which means that it is going to format A in the form of a 7 places of decimal in the floating point. So let's run this program. So the output is 7 places in decimal. A is 3.1416. Output is 7 places of decimal. 1, 2, 3, 4, 5, 6 and 7. So this is what is meant by percentage 0.7f. Percentage is the starting and conversion character, f is the ending. 0.7f defines the decimal places. So if I put 0.8, so it will give 8 places of decimal, and if I write, let's say 20, so it will give 20 places of decimal. So see, now it is 20 places of decimal. So this is what is meant by this format specification. Let's run few more programs. So now I am going to run 0.7f in the form of a character vector. Format specification is in the form of a character vector. So output will be in the form of a cell array of character vectors, or a single cell array with a character vector inside it. So let's run this program. So A is pi and format specification is a character vector. Same thing in a character vector form. And now I run this. So C output is in the form of a 1 by 1 cell array and 7 places of decimal. Again I put it as 20. So it will become 20 places of decimal. Let's see few more examples. In this example, A is a array of doubles and format specification is in the form of a string single string scalar, and string compose is formatting A according to the format specifications. Let's see this program. And now this format specification is applied to all the elements of array A. So let's run this. So see that all the elements of array have 7 places of decimal, and if I write over here again 20, so they will be having 20 places of decimal. Now earlier it was string, now it is in the form of a character vector. So if the format specification is in the form of a character vector, the output will be in the form of a cell array of character vectors. So this is the program. Now I run this. So see, this is the input and this is the output is in the form of a cell array of character vectors. Now this program, in this I have A as a array of uh, doubles in which each element is pi, and format specification is having format specifications for each and every element. So A is of the size 2 by 4, whilst format specifications are also of the size of 2 by 4. Each element of the format specification is different. First element is 0.2f, second is 0.3f, third is 0.4f, and so on in the form of an array. So let's see this. So for every element there is different format specification. So A is 2 by 4 and 4 by 2 and format specification is also 4 by 2 and the output is according to this. So how the output has been formatted? So output has been formatted like this. First element is taken and it is formatted according to 0.2f. So the output over here is 3.14, 2 places of decimal. Then next element is taken as this one. This is according to the 0.4f. So this is applied as this one, which is 4 places of decimal, and so on up till 0.8f. So 0.8f over here applied to this one, and we have 8 places of decimal. Now in this 0.3f is applied over here, 3 places of decimal, and 0.9f is applied over here as 9 places of decimal. Now all the format specifications are in the form of a string array, so the output is also in the form of a string array. Let's see some more examples. If A has multiple rows, then compose returns string as a str as a string array or cell array with the same number of rows. Compose repeats format specification in each row of str with formatted values from the corresponding rows of A. So in this example, A is a 4 by 2 array of doubles and format specification is a single array of strings having only a single row, that is it is a row vector array of strings. So string compose function formats the A with the format specifications. Now this format specification is applied to all the rows of A and it is um, copied for all the rows, right? So let's run this program. So in this you can see, as we run this program, so we have got only this one row of format specifications while we have 4 rows. So this format specification is applied to all the 4 rows, repeating itself. So how repetition is being done? So repetition is done in the following way. 1 taken as 0.2f and applied over here as 2 places of decimal. Then 7, again 2 places of decimal over here, not shown properly. Let me show it properly. So 7, 2 places of decimal, and over here all the values in the second column with 3 places of decimal. 2 with 3 places of decimal shown over here. Then 8 with 3 places of decimal shown over here. So in this way, if the number of format specifications is less, it applies to the multiple rows for all the rows of A. Now A is equal to a row vector of pi, and format specifications can be written in the form of a text. Means you can add the text in the format specifications. So you have written this text starting from here as a string vector. So over here up till here, this is the first string, and then this format specification. This is the format specification, first format specification. This will be applied to this pi, and then again a string, and this is the second format specification applied to this second pi. So let's run this program. So when I run this, format specification is this: the value of pi in 2 decimal places is 0.2f, and when conversion is done, so 3.14 is applied over here because of this 0.2f format specification. Then over here 0.5f format specification is applied over here and applied to the second pi, which is converted to 5 places of decimal. So the value of pi in 2 decimal places is 3.14, and the value of pi in 5 decimal places is 3.14159. So this way you can write any text in the format specification. Please take care that over here it is in the form of a single string. This is a single string up till here. See, the single string is there in the format specification. Over here again, this is x is a row column vector, and y is taking the square of the elements of the row column vector x. Now format specification is applied over here. This is the first element format specification, and this is the second element format specification, and in between from here to here is the text, and this format specification will be applied to the elements of x, and this format specification will be applied to the elements of y. So this will be repeated for each of the rows of x and y. Since x and y are column vectors, so we can say one by one specifications will be applied to each of the elements of x and y correspondingly. So let's run this program. So see, this is x, this is y, and then we applied the format specifications. So this is 1 into 2 is 1, 1 square is 1, 2 square is 4, 3 square is 9, 4 square is 16, and 5 square is 25. So this way this format specification is applied. If the number of columns in A exceeds the number of operators in format specification, then compose repeats format specification as an additional column of str. The extra columns of A contribute formatted values to the new column in str. So if the format specification you write the time is this is the string, and over here you have got 2 format specifications. This is the first format specification, and this one is the second format specification. But over here in A you have 2 rows and 4 columns, means you have two extra specifications, extra elements, data values uh, in excess of the format specifications. We have only two format specifications and we have 4 data values in a row. So for those values, these format specifications will be repeated. So this is the program, and let's see. The time is this colon this. So first format specification a percentage d is applied to 8, then colon is put, and then second is applied to 15. So the combined result is this, the time is 8 colon 15. Now we have two extra elements over here, 9 and 30. Again this specification is applied over here, and this specification is applied over here, and the combined result over here is generated as 930. Similarly for the second row, the time is 1020, and uh, the second row second column, the time is 1150. So this way the input array is formatted according to this time specification. Let's see some more examples. If the number of columns in A is less than the number of operators in format specification, then compose does not format values using those operators. Instead, compose puts unchanged formatting operators in str. However, compose translates all the escape character sequences except for double backslash and double percentage. So if we are having number of format specifiers which are more than the number of data values, then we write the format specifiers as such. So over here in this we have one, and over here 2, then over here 3, and over here 4 format specifiers, but we have 2 rows and 2 columns. So in each row we are having 2 less, means only 2 data values, while we have 4 format specifiers. So 2 format specifiers are in extra. So how do MATLAB formats such a string? So let's see such a array. So let's see. So format specifier over here is this and A is this. So let's run this program. So see, the last two format specifiers, they are not processed, they are written as such. So over here same thing is written as such because there is no data value on which the format specifications can be applied. But for the first two, the format specification is applied. Percentage G applied to 12, and here it comes 12. Then colon, as such colon is translated, over here colon is placed, and then 27 is applied over here because of this particular format specifier, and the text as such is written from here to here. And similarly for the second row, but since no data values for this, so this is written as such. Let's see some more. So str compose format specifiers a1 a2 an means if there are multiple arrays, so format data values from multiple input arrays and concatenates all the formatted values means a1 a2 an are concatenated. When compose uses formatting operations from format specifiers to convert data from an input array, then those formatting operators become unavailable to the following input arrays. For example, if format specification is uh, %f, %d and %s, and a1 has two columns, then for operators %f, %f are applied to the values in a because a1 has two columns only, and the remaining %d, %s are applied to the columns of a2 and so on. So let's see the example for this. So A1, A2, 2 by 2, 2 by 2. So we have total of 4 elements in a row if A1 and A2 are concatenated. And how many format specifiers we have? We have 4 format specifiers. So the first 2 format specifiers will be applied to the A1 columns, and then the remaining 2 format specifiers will be applied to the columns of A2. So let's run this program. So see that first two, 1 2, they have the format specifiers 0.2 and 0.3. 0.2 is applied to the data values 1 and 3, and then 0.3 is applied to the data values 2 and 4, and then 0.4 is applied to A2 values. Earlier it was A1 values, now it is A2 values. 0.4 is applied to the first element of A2 and the um, second element of first column of A2, right? Then 0.5f applied to the last column of A2, this way. Let's see a few more examples. If the number of columns in the last input array an exceeds the number of remaining operators, then the compose adds an additional column to str as described in the previous syntax. So a1 having 2 columns, a2 having 2 columns, a3 having 2 columns. So in total, if a1, a2, a3 are concatenated, we have 6 elements in a row. But how many format specifiers are there? 1, 2, 3, 4 and 5. Means we have one less format specifier than the total number of elements in a row. So what will happen? Let's see this. So when we run this program, see very carefully what will happen. So the first format specifier is applied to the first column of A1. 0.2f is applied to the first column of A1, and then 0.3f, the second format specifier, is applied to the second column of A1. Then 0.4f, which is the third format specifier, is applied to the first column of A2, and then the fourth format specifier is applied to the second column of A2, and then 0.6, which is the last format specifier, is applied to the first column of A3, this one, 9 and 11. Now we are left with the last column of A3, which is the second column of A3. For that, again the same thing is repeated up till the second column of A2, and in the last column we have applied the format specification of 0.6 to the last column of A3, which is the second column of A3 over here. 0.6f is applied to this values, means 10 and 12. So in such a case we have this thing the same as this thing, and also this thing the same as this thing, and only the last column is different. Again, since the input is in the form of the format specification is in the form of a string array or string scalar, so the output will also be in the form of a string scalars. Let's see some more examples. So if the number of columns in AN is less than the number of remaining operators, then the compose puts the last unchanged operators in the string. A1 is having 2 by 2 and A2 is having 2 by 2 size. So format specifications we have 1, 2, 3, 4, 5. In a row, if A1 and A2 are concatenated, we have 4 elements, but the format specifiers are 5. So what will happen to the last extra format specifier? Let's run this program. So see, the format specifiers are applied 0.2f to the first column of A, 0.3f to the second column of A, 0.4f to the first column of A2, 0.5f to the second column of A2, 0.6f is written as such because there is no data value corresponding to this, right? Let's see some more examples. Compose also translates the escape character sequences in format specifiers. Escape character sequences represent non-printing characters or specify actions such as new lines or tabs. The compose function can return multiple pieces of formatted text as string array or cell array of character vectors. So in this particular program, we are composing a text and we are translating the escape sequences and composing them into the actions, right? So this is the string name, this is a string, then this is the tab escape sequence, then again date of birth is a string, then again \tab t is the escape sequence, again then location is the string, right? So again we are putting some more values, Jones date of birth and UK with the tabs, Simpson date of birth, USA with the tabs, and now we are composing that string. Let's see what is the result of this operation when we are composing this string. So when we run this program, so see the tabs have been converted. This tab has been converted to arrow. This tab has been converted to arrow, indicating that it is a tab, and similarly for the other values. So this way the escape sequences are translated to the actions or the uh, uh, operations they are meant for. Last, don't this one is about how to escape the escape sequences. So if I run this program, so double backslash, so um, in this one is the escape sequence, but I've written a double backslash, so this will not perform the escape sequence, it will escape the escape sequence. So let's run this. So see, the escape sequence has not been converted, it has not given the action, so its action should be new line action. So this, if it has been converted, this should come in the new line, but it has not because of the double backslash. So in order to convert it to the action, so we will remove one backslash and now we run it again. So now see that new line escape sequence has been performed and action has been performed and the text has been shifted to the new line. So this is the way how compose function works in MATLAB. So with this I end my video tutorial for compose function. I hope you have understood the concepts properly and I hope you have liked this video. Thanks for watching this video.